All right, so we're taking a look at the question number 14 in Frogs, Fleas, and Painted Cubes, Investigation 1. And it is a connection between the business world and quadratics. The question, the equation P is equal to D times the quantity 100 minus D gives the monthly profit, P, a photographer will earn if she charges D dollars for each print. Now, why would this be a quadratic relationship? Let's think about this. If she gave her pictures away for free, would she make any profit? No. Now, if she charged so much that no one bought her pictures, would she make a profit? No. So there are going to be two prices where she gets no profit at all. Once if she gives away her work for free, and again when she overprices her work to the point that nobody wants to buy it. So the trick is, in between those 2 points, there will be a maximum profit possible. And that's what we're going to find. Sophia, are you ready for this? Yes. Good morning. All right. Yeah, and that will be saved for posterity's sake. All right. So we are first going to make a table and a graph for this equation. All right, so what are our two variables? Okay, P and D. Which one is independent? D. And dollars for each print. So this is the cost. So as the cost of the print goes up, less people will buy the print. That makes sense. And we have P for profit. Let's start at 0. And what do you think we're going to have to go up to? We're probably going to have to go up to 100, because I know that 100 minus 100 would be 0, so that's going to be when she's totally overpriced her work. So if I'm starting at 0 and going to 100, what should I count by? Let's count by 10s, because it would be ridiculous to count by 1s. We'd be here far longer than we'd want to be. Now the cool thing about parabolas, and I'm pretty sure this is going to be a parabola, as soon as I've gotten to my maximum, I know that the rest of the table will be symmetrical. Therefore, I don't need to worry about doing the whole table. I really only have to do half of the table. So I'm going to pull up my calculator. All right, so if I plug in 0, I want a little more space to work. Goodbye. It's not mean. She doesn't want to see this. All right. So we have P is equal to, what's our cost? What cost should we start with? 0. Okay. So P is equal to 0 times 100 minus 0. So 100 minus 0 is 0. So we get profit is equal to 0 times 0, which is, okay, maybe I didn't need to start with that one. Let's now go to 10. So profit is equal to 10 times 100 minus 10. Well, 100 minus 10 is? So we get 90 times 10, which is? So profit at $10 a print is $900. Let's try 20. So if our profit is equal to $20 for every print, and then we have 100 minus 20, because 20 people aren't going to buy the print because it's now costs money. 100 minus 20 is? Times 20, which is? Let's repeat the process. Now, obviously, this is good mathematics, but I'm sure at some point you're going to tire of watching us do this 10 times. Okay, Ethan likes it. He thinks it's amazing. But right now, I'm pretty sure that when I plug 30 in, I'm going to end up with 30 times 70. 30 times 70 is, okay. With 40, I'll get 40 times, which is 2,400. I will get 50 times 50, which is Oh, 60 times. And so now the numbers are going to repeat. Now, if we charge $50 per print, if we charge $50 per print, will we sell out? No, we won't. However, that's where our maximum profit is. So when companies figure out the pricing of an object, they are not trying to sell as many as they possibly can. They're trying to maximize their profit. So they're picking the price at the apex or the vertex of their parabola, not necessarily how much they can get for how much they can sucker one person into spending for it. All right, so then estimate the price that would produce the maximum profit. Well, we don't need to estimate. We know it's $50 per print. See how are the table and graph for this situation similar to the ones in problem 1.1, and how are they different? Well, this is clearly a quadratic relationship, which is a parabola. Is this parabola opening up or opening down? This is opening down, so both parabolas have a maximum point and they're opening down. However, do they have different values in the table? Yes. So they have different x-intercepts. The y-intercept is the same. It's 0 for both of them. And they have a different line of symmetry and a different vertex. Did I fully answer your question? Okay.